This video will cover lesson 7, the lesson we did today in class. This is on making acceptable moves to equations. This goes hand in hand with the Desmos slide deck that we did today. So I'm not going to cover every slide that we went through. In fact, I'm not going to cover the warm-up slides, but I am going to start with this one. And so this is where we're considering two different equations. And we know that the first equation is a true statement for a certain value of x. And we are supposed to explain why the second equation must also be true for the same value of x. So what I did today was we did things a little different. I actually said, let's look at the second equation right here. And I asked those of you to think of a number that I could multiply by 3, which is x, in order for me to get a value of 21. And we talked about that value of x was 7. And we know that because 3 times 7 is equal to 21. That is one way to look at it. Another way that some of you would necessarily look at it would be like this. You'd say 3x is equal to 21. Therefore, I'm going to divide both sides by 3. Because I have multiplied 3 times x, and in order for me to undo, or the inverse operation of multiplication is division, as we heard today in class, that if I divide both sides by 3, 3 divided by 3 gives me 1x, and 1x is equal to 7, because 21 divided by 3 is 7. Therefore, we drop the 1 in front of the x, and we simply say that the value of x is equal to 7. So I already know what the value of x is, and I want to make sure, does it indeed, if I substitute it in right there, will it indeed be a true statement? So what I'm going to do is I'm going to use this value of x is equal to 7, and I'm going to substitute it in. So I'm going to go 3 times 7 minus 5, and I want to know, does that equal 16? So I know that 3 times 7 is 21. And when I take away 5, I want to know again, does that equal 16? 21 minus 5 is equal to 16. And 16 is equal to 16. Therefore, yes, both sides are equal to each other, the right and the left. Therefore, x is indeed the solution for both. Can you explain why? So in this dialog box, you would have indicated that the value of x is equal to 7 and x is equal to 7 for both equations. That's what you can say in that dialog box. All right. So the next slide in Desmos had to do with explaining acceptable moves. And one of the things that we did was we looked at two sets of equations. And we were told that one was true and the other one was false, and we needed to justify and verify. So I'm going to look at the first one, and it's going to say 16 is equal to 4 times the quantity of 9 minus x. We're not solving for x. We are simply justifying why I can say that those are both true. And so what I'm going to do is I'm going to rewrite 16 is equal to 4 times the quantity of 9 minus x. And I need to prove that it is indeed equal to 16 is equal to 36 minus 4x. So I'm hoping that you would have noticed today that what we did was we could use the distributive property. And the distributive property tells me that I can multiply 4 times 9, which is 36. And then I'm going to subtract. I'm going to bring in this operational symbol. And now I'm going to multiply 4 times x, which is 4x. And I'm going to notice, obviously I didn't do anything to the left-hand side, so it's still equal to 16. So you're going to see that I have the exact same equation. So these are both true because I can use the distributive property. So you could see what I did was I typed or wrote into the box, I can use the distributive property on equation number 1. I just left it like that because I ran out of space and I don't want to take up too much time. So now what we're doing is we're looking at the second set of equations. So I'm going to draw a squiggly line and I'm going to try to figure out what did they do because we are being told they are not equivalent. So what I'm going to do is I'm going to write both equations down with a little bit of space. So one of the things we want to remember is we can do legal moves. We always have to look for balance. Whatever I do to one side, I need to do to the other. Well, I'm going to notice that I've got 14x over there on the left-hand side. So I think what happened was they added 5x to both sides. And when I add 9 and 5 together, I get 14x. But if I add 5x to 5x, I get 10x. And that's not what they got. They got 14x right here is equal to 4. So these are not equivalent. They did not do the balanced move of what should they have done. Well, what they should have done in order for it to be balanced, like they balanced it, they added 5x to both sides, but that's not what I ended up with. I ended up with 14x on the left and only 4 on the right. So what they did was they subtracted 5x because 5x take away 5x becomes 0, which leaves me definitely with 4. However, they didn't do that on the left. So what I'm going to write here is they are not equivalent because they did not do balanced moves to both sides of the equation. So you can see what I wrote, that 9x is equal to 5x plus 4 and 14x is equal to 4 are not equivalent because they did not do a balanced correct move. They took away 5x from the right, but added 5x to the left. Thus, these are not equivalent. Moving on and looking at the next prompt, explaining moves. Again, number 2. Again, we're going to look at these two equations and we are going to figure out what did they do. So we know that the first one is right. So again, what I'm going to do is I'm going to write each one down with some space so I can then explain. So what they did here, and I'm only going to look at the first equation, we know that it's true. So what did they do? So if I look here, I started with 5x and I now have 3x. Okay, here's the 24. So they didn't do anything to the 24. But what they did do was they took away 2x from the right. And again, remember that whole balance piece that whatever I do to the one side, I have to do to the next side. So on the right side, I took away 2x. And on the left side, I'm going to take away 2x. And when I do that, notice I draw a line because in a sense, I'm kind of doing moves to an equation. 5x, take 2x away. I have 3. And I've got 24 right here. So this is true. So they are both true because we took 2x away from both sides of the equation. So I wrote here, we took 2x away from both sides of the equation. It's a balanced move. Again, I took it away from the left and the right-hand side. All right, so we had a really nice discussion in our third period class about this next set of equations right here. And I love the conversation we had today. And I'm going to try to replicate that conversation below with a diagram of what we talked about. So I'm just going to rewrite it with some space. What we talked about in class today was we actually looked at the second equation right here. And we noticed that they took x and they took half of it. Okay, so if you take half of x, you say, I'm taking 1/2 of x. And then we continued along that path and we said, okay, I know if I take half of 18. In other words, if I take 18 and divide it by 2, that's taking half, I get 9. So we took half of 18. All right, that's 1/2 of 18, which is dividing it by 2, and I got 9. Okay, so we could see what they did there. But then I challenged our thinking to say, well, if they took half of x and they took half of 18, why didn't they take half of 8? Okay, they didn't. They forgot to. So this is why it doesn't work. Because what they should have done is they should have taken 1/2 of 8, which would have indeed been 4. That's what they should have done. But they didn't do it. Okay? So because they didn't do it, it's not true. So what I'm going to do is I'm going to write that in the dialog box so you could copy that down. All right. So what I wrote was they took 1/2 of x and 1/2 of 18, but they forgot to take 1/2 of 8. Therefore, the equation is not equivalent. Again, I'm going to stress to you that when you do a balance move, an acceptable move needs to be done to everything on both sides of the equal sign. So you can go ahead and pause the video or stop the video right there and make sure you get everything down, because we are actually going to go on and look at the next acceptable move, number 3. And what I don't think, or we did number 3, and we, yes, definitely did number 3 today. So again, we know that this first set of equations is true, and we know the second set of equations is not true. So let's go ahead and look at the first set. And I loved, a student had said to me earlier that we know that if I were to do distribution right here, okay, let's just do distribution. What would I have ended up with? I would have ended up with negative 6x plus negative 27, right, is equal to 12. That's using simple or straightforward distribution. Well, I'm looking here at 2x plus 9. I still am not at 2x plus 9 is equal to 4. It is equal to negative 4. And that's, plus 12. So these two don't look like each other, okay? So that's not what they did. But I love that we talked about distribution, because distribution means to multiply. So that was terrific. So what I'm going to do is I'm going to erase this, and let's see if we can figure it out. All right, so I'm going to erase the whole thing up here just so we're kind of clean slate. All right, so I am going to rewrite everything. All right, so you can see that I rewrote everything. And I'm going to notice something here. I'm going to notice that inside this parentheses, this stayed the same. All right, and somebody said to me today, I asked the question, what do I do when I distribute? And somebody answered the question that I multiply, okay? Then I asked the question, so how do you undo, or what's the opposite of multiplication? And somebody else said, well, it's division. So what we're going to do in this case is that we are going to divide the left side by negative 3 and the right side by negative 3. And look what happens. Negative 3 divided by negative 3 is 1. 1 what? 1 2x plus 9, right here. 2x plus 9. We don't write the 1 in front of the parentheses. I don't have to. So 2x plus 9. And what's 12 divided by negative 3? Negative 4. That is why it is equivalent. We divided both sides by negative 3. I want you to go ahead and write that into that dialog box right there. And remember, when I divide both sides by -3, that is an acceptable move because what I did on the left, I absolutely did on the right. So we kept it balanced. All right. So now let's take a look at our second equation right here. We have 6x minus 6 is equal to 3x. X minus 1 is equal to 3x. I want you to think about that for a minute. I'm going to recopy it. And I want you to think about what we did in this move, in this equation right here, about dividing. I want you to think back to this previous slide here, what we did here in this equation, all right? And see if you can figure it out. So hopefully you saw that, wait a minute, I went from 6x to x and from 6 to 1. Or I could go the other way. Kind of like what we did previously with that 1/2. Well, if I have x, how do I get to 6x? Well, I multiply it by 6. How do I get to 6 from 1? I multiply it by 6. So in this direction, I multiplied by 6. In this direction, I multiplied by 6. Okay, so remember what we said. If I multiply the left-hand side by 6, that means I've got to do the same here. And did they do that? No, because if they would have multiplied this by 6, this would have been 18x, but it's not. Okay, so now let's go the other way. All right? So that's what I did today, was I went the other way. So let me just erase this, make this all neat again. So instead of multiplying the bottom number by 6, the bottom equation by 6, let's divide 6x by 6, I get 1x. What is 6 divided by 6? 1. And if I would have taken 3 and divided that by 6, I would have gotten 0.5 or 1/2. So 1/2 or 0.5. Well, that didn't work either. So they are not equivalent because they did not make the balanced move of either multiplying everything by 6 or dividing everything by 6. Either way is good. All right, so what I wrote here is we did not divide everything by 6. We forgot to divide 3 divided by 6. It's not balanced. All right, so those were the explaining acceptable moves. And again, notice we never solve for anything. All we're trying to do is recognize the error that happened and realizing what we can and cannot do when we look at equations. All right, moving on now to the next slide. Here's another one. We did not do this one in class today, and I'm going to quickly go through, or no, we did do this in class. My apologies. I know that we did both of these. Sorry about that. So I'm going to quickly go through this. So hopefully this will make a little bit more sense. Let me take care of the left equations first, and then I will take care of the right equations. All right? So you can see here I used blue to indicate what happened. These are equivalent because they basically use the commutative property, which is where I can move things around. So I'm allowed to do that. So notice that on the left-hand side, the 5x stayed the same. We didn't do anything to it. We kept it there. And what happened on the right-hand side? Negative x or minus x went in front and plus 3 went in the back. Totally okay to do. It's easy a lot of times for students to see things more clearly. So that's what happened on the left hand with the left equations. So what I added here was I moved minus x using the commutative property, and I'm allowed to do that. I can rewrite things providing that I make sure I always watch the signs or my mathematical operations. So now looking at this second equation, we know that it is not equivalent, and so they did something to this. And again, I'm going to go back to distributing. If I distribute, I am multiplying, right? Negative 11 times x and negative 11 times 2. And we're going to notice, or I could have divided everything. by negative 11 because I undo multiplication by dividing. Well, look what they did here. Was they simply took negative 11 and they added 11 to both sides right here. And when they added 11, you can't do that. You cannot, this is not acceptable. It's not a balanced move because you are multiplying, and I can't go from multiplication to all of a sudden adding to both sides. So that is why this isn't true. It's not equivalent because they added 11. What they should have done is divided both sides by 11. So let's just say it's not equivalent because they added 11 to both sides instead of dividing by 11. So you can see that I wrote they added 11 to both sides instead of dividing both sides by 11. All right, now I think we're done with acceptable moves. And this next couple of slides had to do with Noah. The last time we saw Noah was buying jeans, but now he's having some trouble solving equations. And in each case, he took steps that he thought were acceptable, and he ended up with statements that are clearly not true. So what we're supposed to do is analyze his work and the moves that he made and answer the question, were his moves acceptable or not? So, and then we're supposed to figure out, well, why did he end up? So look at what he ended up with. We all know that 6 is not equal to 1. So let's see what he did. Here's the original equation. Okay, we agree. There it is. And then what he did was he applied the commutative property. So again, thinking about the commutative property as being where I can move things around. So what did he do? He took this minus 3 right here and he moved it to go right and back of the 4, which is totally acceptable move. We can do that, right? Then what did he do? He combined like terms. All right, so what do you mean by combined like terms? He took the 4x, and if I take 4x and I take 3 of them away, what am I left with? I'm left with 1x. All right, so we can agree with that. So he didn't do anything to the left-hand side at all. He left it as x plus 6. Totally good. Everything is good so far. All right, so he left the left side around. He combined like terms, and he got x plus 1 is equal to x plus 6. Okay, there's nothing wrong with what he did. Okay, so yes, all of his moves were indeed acceptable. But why did he end up with a false equation? Well, I want you to go back right here and look there. How can I have the same value of x and add 6 to it on one side and make that equal to just adding 1? It doesn't work. I can't have like 3. Remember, if x is equal to 3, remember it's going to be the same on both. So if x is equal to 3, well, we know that that's 9. And if x is equal to 3 on the right-hand side, well, that's 4. Well, that doesn't work either. So basically, he ended up with a false equation because his original equation is not true. It's not true. His original equation is false. And that happens sometimes. We're going to see that next semester next semester where it's not going to work. And remember how points on the line, if they don't sit on the line, they're not a solution to the equation. Well, this equation is wrong. So that's why it doesn't work. All right, moving on. Let's look at another one. We did not do this one today in class. So this one is for added bonus, just to help you give a little bit more information. All right. Still having trouble solving equations. He thought that he did everything right. And again, he ended up with this 2 is equal to 3 and 2 is equal to 3. So let's take a look at each one. So I've got the original, and then he applied the distributive property. So if I think about what he did, and we've seen this before, we're going to multiply 2 times 5 and 2 times x. So 2 times 5 is 10, and 2 times x is 2x. So I agree there, and then he didn't multiply the 2 by 1 because he can't, because it's not inside the parentheses. So everything looks good here, and on the right-hand side, everything is the same. All right, so then he said he subtracted 10 from each side. Okay, so I see what he did was he took this and he's going to take this 10 and he's going to take it away right there. And if he takes it away over here from the 9, I get -1. All right, because 10 minus 10 is 0. Okay, that goes away. Leaves me with 2x minus 1. That's good. I'm good there. And he took away 9 minus 10, which is -1. Perfect. So now I've got 2x minus 1 is equal to 3x minus 1. Okay. So now what did he do? He added 1 to both sides. All right. So if I add 1. Okay. So if I add 1, that goes away. Okay. I agree there. And add 1 there, goes away. Yes. All right. So then what did he do? Well, 2x is equal to 3x. Again, I'm going to ask you, if I put the same number in for x, if x is equal to 2, 2 times 2 is 4. Remember, 2 times 3 is 6. Well, that doesn't work. How about 1? 1 times 2 is 2. 1 times 3 is 3. Well, that's not going to work either, right? And so basically, he did everything right, I think, right? Unless you guys are seeing something else. So go ahead and think about that a little bit. So hopefully you gave this a little bit more thought. And we were plugging in numbers. So one thing I want you to think about is, and I'm going to, I don't know if, I think I can pull this up just a little bit. Right? I'm going to erase my little line here. So what happens if I put in 0? What happens if I say that x is equal to 0? Because x can be 0. So what's 2 times 0? 0. And what's 3 times 0? 0. So where did he go wrong? Well, his moves are all acceptable except for this last one right there. So not the 2 is equal to 3. I'm talking about the 2x is equal to 3x. So what he did was, this is what he did. He divided both sides, or what did he say? He divided both sides by x. Okay? Well, that's okay, but not really, because you end up with this false statement. And typically, ladies and gentlemen, when we solve, we are looking to get a value of x. So what would have happened if instead he would have subtracted 2x from the left and subtracted 2x from the right? If I have 2x and I take 2x away, I get 0. And when I have 3x and I take 2x away, I get x. So there is his error. So the answer is x is equal to 0. Okay, that's a really challenging one to think about. And I just want you to think about what I just talked about. All right, moving on and looking. Here were your exit tickets. So I'm quickly going to go through these next couple of slides just to give you the final answers. What we're doing is what move was made. I'm not solving. I want to know what move was made to get to 5x is equal to 2. As you can see here, I took 3 away from the left and 3 away from the right. So I ended up with 5x is equal to 2. Looking at this one, again, I'm going to think about a move that was made. So in this exit ticket, I divided both sides by 5. So 5 divided by 5 leaves me with x minus 3. And 5x divided by 5 is simply x. So x minus 3 is equal to x. And there you go. That is it. Great job. hopefully that helped.